Okay, so we're going to talk about independent and dependent events today. So I want to explain a couple of things. So in my hands right now, I have a penny and a number cube or a dice or whatever you want to call it. Okay? So if I flip the coin and roll the dice, one does not affect the other. Does that make sense? Okay? What I roll on the dice does not affect what I flip on the coin, right? So these events are independent of each other. Okay, you good with that? Yes or no? Okay, because what I get on this does not affect this. Yes? Okay. So, dependent events, I have some markers up here, okay? I have all these things right here, okay? So, I have 2 green markers, 3 orange, 1 pink, and 4 yellow. You good with that? Okay, so 10 total markers. So, if I randomly go in and I pick out a green, the probability of me getting a green is 2 out of 10, right? If I don't replace that green marker, what's the probability of me getting a green again? 1 out of 9. Does that make sense? What happened there? What happened there?
You took a marker out.
I took a marker out, but I also took a green marker out, so it reduced the number on the top and it reduced the number on the bottom. Okay? So it reduced both numbers. So we have to pay attention to that. Okay? So they are dependent events. One depends on the other. Okay? So independent, if it doesn't change based on what you did first, dependent, if it doesn't change, it's dependent. If it does, I'm saying that backwards. Oh my gosh. If it matters what you did the first time to the second time, they're dependent events. If it doesn't matter, you're independent, right? Okay? So right now, you are dependent people because you live with your mom and dad and you need them for their support, right?
Basically.
Yeah, okay. So right now, I'm an independent person because I support myself. Well, me and my husband support myself. So, I guess I'm dependent on him. But if I needed to live independent of him, I could. Okay, right? So let's break that down just a little bit more. Okay, so the probability of 2 independent events can be found by multiplying the probability of the first event by the second event. So if we have 2 number cubes, 1 red and 1 blue, what is the probability that the outcome of the red number cube is even and the blue number cube is 5? Okay. So probability of the red number cube. So even on our options on our red number cube, our options are 1, 2, 3, 4, 5, and 6. What of those options are even? 2, 4, 6. 2, 4, 6. So that's technically what? 3 out of 6, which reduces to what? 1/2. Okay? You pretty good with that? Okay. On the blue number cube, what is the probability of a 5? Well, our options are still 1, 2, 3, 4, 5, 6. So the probability of getting a 5 is 1 out of 6. Okay. So reading this line, it says the probability red number cube is even and a blue number cube is a 5. That means we multiply 1/2 times 1/6 and we get 1/12. Okay? So 1 times 1 is 1, 2 times 6 is 12. So the probability that we get a even number and a blue number cube is 1 out of 12. Okay. Makes sense. Those 2 are independent events because the number cube doesn't affect the other number cube. We're just multiplying the 2 fractions together, okay? So look at example 2. There are 6 black socks. This is like the pen example. And 4 white socks in a drawer. Okay? So if 1 sock is taken out without looking, and then a second is taken out, what is the probability they will both be black? So here's my socks. Okay, I got some black ones, and then 4 white ones. Y'all good with that? Okay. What is the probability that the first sock is black? 6 out of 10. I'm going to reduce that to 3/5. Remember, we reduce things as much as we can, right? Okay. Once I take this black sock out, because I drew a black sock the first time, what's my probability that my second sock is black? Well, now I have 1, 2, 3, 4, 5 out of 9 because I took a sock out. So not 10, it's 9. Does that make sense? Okay. Now, what's the probability of 2 black socks? Well, you would multiply 3 over 5 times 5 over 9. Because you multiply them together once you get them, the probability of each. So, I'm going to cross reduce because I like to do that. If you don't understand that, just multiply straight across. 3 times 5 and 5 times 9. But if you do it, and it's either way, it's going to simplify out to 1/3. Okay? Okay, let's keep on going. You ready? Okay. A card is drawn from a deck of cards numbered 1 through 10, and a number cube is rolled. Determine each probability. These are independent events, right? Okay. So I'm going to write my options on the cards. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then the number cube is 1, 2, 3, 4, 5, 6, right? Okay, what's the probability of a 10 in the cards? 1 out of 10. What's the probability of a 3? 1 out of 6. Because it's out of the number cube, right? The first one is the cards. The second one is the number cube. So 1 times 1 is 1. 10 times 6 is 60. So the probability of a 10 and a 3, a 10 in the cards and a 3 on the number cube is 60. Yes? See it? See where we're going? Okay, remember these are independent of each other. So right here, 2 even numbers. Okay, so let's look at the cards first. What's even? 2, 4, 6, 8, 10. So that's 5 out of 10. Okay, and then even numbers over here would be 2, 4, 6. So that's 3 out of 6. What can those both be reduced to? 1/2 times 1/2. Do you see I'm reducing it here to these fractions? Okay, so 1/2 times 1/2 is 1/4. Okay. Number 3, 2 prime numbers. Okay, yesterday we talked about prime. Okay, what are going to be the prime numbers on the deck of cards? 2, 3, 5, and 7. Right? Y'all agree with those? How many is that? 4 out of 10. What are the prime numbers over here? 2, 3, and 5. So 3 out of 6. Can I reduce 4/10 to 2/5? Can I reduce 3/6 to 1/2? Can you just multiply it 4 times 3 and 10 times 6 and then reduce it there? Yes. Okay, you can. But I like to simplify it as low as I can before so I don't have to multiply big numbers. And I should have got 1/5. Okay, let's look at number 4. The probability of a 9 and an odd number. So 9 is just going to be 1 out of 10. Okay, what about an odd number? What is that? 1, 3, and 5. So that's 3 out of 6, which reduces to 1/2, which is 1/20. Okay, the probability of 2 numbers less than 4. Okay, less than 4 means it does not include 4. So that's going to be 3, 2, and 1. And same thing over here. Less than 4 is going to be 3, 2, 1. So we have 3 out of 10 on the first one, and then 3 out of 6 on the second one. So I'm going to go 3/10 times 1/2, and I'm going to get 3/20. Okay, so numbers greater than 5. So our numbers greater than 5 are going to be 6, 7, 8, 9, and 10. So 5 out of 10. And our numbers greater than 5 are going to be 6 over here. So 1 out of 6. I'm going to reduce this to 1/2. 1/2 times 1/6 is 1/12. Understand that every problem, we go back to a full set of pencils. So understand that concept, okay? So look at number 7. There are 4 red, 6 green, 5 yellow pencils in a jar. Once a pencil is selected, it is not replaced. Determine each probability. But when we go to the next number, everything's back in the jar. Does that make sense? We're not starting from where we left off on when we start on number 8 from number 7, okay? So, like, for example, number 7. How many, we're going to do a red pencil and then a yellow pencil. So my red pencils are 4 out of 15 pencils total, right? So if I pull that red pencil out, this is like the highlighter example, how many pencils are left? Well, there's 14 total for the yellow, okay? And then how many yellow pencils are in the jar still? 5, okay? So we can simplify. I would simplify. This would be divisible by 3, divisible by 1. This is divisible by 2, and if you don't want to simplify, it's fine, just multiply straight across. I just didn't want to do 15 times 14. 2 times 1 is 2, 3 times 7 is 21. At the second one, number 8, we're starting back with 15 pencils again. So we're doing green. Okay, so first set, out of 15 pencils, there are 6 green pencils. If I take a green pencil out of the jar, I only have 14 pencils left in the jar, and I took a green one. So how many green ones are left? 5. So it reduces on top and on bottom. So I'm going to simplify. They're both divisible by 5. This one is divisible by 2 and 7 right there. So actually can do it one more time, but we'll go ahead and attempt the rest of them, and then I'm going to put the answers up here in just a second. Okay, so here, check your answers right here, and let me know if you have any questions after that.
I don't know if you can insert just a...
No, I'll just hold it there. So look over these, keep looking, and then they can press pause.
They won't.